So, yes, class. Assalamu alaikum.
Alaikum assalam, ma'am. How are you?
I'm good. How are you all?
Alhamdulillah.
Okay, class. So, we had started with diffraction. Let's just quickly complete with this topic, diffraction, so that wave optics will be over. Today, you all have the test also of interference. Just interference. I'm taking, though interference is itself such a huge topic. So, I hope you all have prepared for it. Okay, so diffraction was the bending of light that whenever the light striked or touched the small obstacles or apertures or the corners, the light bent. So that results into a geometrical shadow. So this is known as diffraction. So diffraction, this derivation we did. For minima, we had found the condition. For maxima, we had found the conditions. So this all we have completed. This numerical we did, and width of central maxima. This also we have completed, width of central maxima. Yes, intensity distribution curve is left. So intensity distribution curve we did, remember, for that interference as well. Intensity distribution of curve. See, for minima, path difference is in lambda. It means first minima will be what? First minimum will be when you place n as 1. So that will give you path difference as lambda only. So for second minima, you will get 2 lambda. For third minima, you will get 3 lambda. For fourth minima, you will get 4 lambda, and so on. Similarly, for maxima, you have n plus 2n plus 1 lambda by 2. So that will be 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 9 lambda by 2, and so on, all the odd multiples that you have. Right, if you place it. So what type of intensity distribution curve that you will obtain? So what type of intensity distribution curve you will obtain? See, class, this will not be constant the way we had the graph for it in interference. See, intensity decreases. Remember, I had told you in case of diffraction, you don't get the intensity same. In case of interference, you have the intensity same. Now, for coherent sources, that was 4i, the maximum one which we obtained. Here, intensity decreases. Now, how much of by this intensity decreases, like I by 21, I by 61? This is calculated through polarization. And polarization, Brewster's law, all this is not a part of your syllabus. So, no need to solve it. Or no need to even remember it. Just remember I by 21 and I by 61. And yes, please remember this value 21 and 61, because at least something tight in your graph in your exam. So like this only, intensity keeps on decreasing. Now what in actual you observe when you perform the experiment of diffraction? You actually see the intensity getting intensity getting decreased. Like if you perform the experiment with the help of laser light by yourself only, even if you yourself perform the experiment by just simply using a laser light, what will happen at the center? No, at the very center, you will obtain same thing you can do. You can just cover the comb, leaving one slit of the comb left. The brush, 2 bristles of the brush, you can leave it uncovered, and rest of it you can cover. So a single slit you will obtain. Pass a laser light, you will notice that since diffraction is occurring, you will observe at the center you get a very, very bright red color. Then you will have dark patterns. Then slightly you will have red color. Then again red. Then red decreases, Just small dot you observe. Then you can feel that yes, very, very dim light is there. That can be observed only in darkness like this, because intensity decreases. So for what points? Lambda, 3 lambda by 2, 2 lambda, 5 lambda by 2. It means intensity. This is the highest intensity of the central maxima, right? Lambda is minima. That's why you are having it again back to 0. Then increasing a bit, decreased intensity, but though it has increased from minima to 3 lambda by 2. Then 2 lambda shows that again minima is 0. Same thing like this, the graph will go on decreasing. So class, you get a question on difference between interference and diffraction. So there you can mention this point. I'll write down myself only. I'll write down the difference between interference and I think I must have written it. The difference between interference and diffraction. Okay, we'll see that later. I think, okay, there are questions over. There, no, yes, there are theoretical questions. Difference is there. I'll write now. If I have not written, I'll share this because that is important. From your theoretical questions, it comes. Note it down. Note this part down. Let's do the numericals. Not numericals, they are theoretical questions. Note it down, then we'll discuss this. Okay, class. See, there are two questions that we are going to discuss. Theoretical questions, theory points I have written. Just understand what is meant by. See, this says that why the path difference of lambda results into minima. We have seen the formula. We have seen it mathematically. We have also seen the intensity distribution curve. What did we notice? That lambda results into minima and lambda by 2 results into maximum. So how can you prove this theoretically if you have to answer? So what you can do, if you want to say, you can take that the path difference between the waves that come is lambda. In the sense, this is a single slit width is small a. Fine. Now this point is A point, this point is B point, and in the middle of it, so this will be A by 2, this will be A by 2. Now see, path difference between waves coming from A is lambda. We have assumed this. That from this point A, because this is diffraction, so one corner we have to take. It means from this A, the path difference will be A, lambda. Fine. So it says that dividing the slit into two equal parts. We have divided the slit into two equal parts. Now see, path difference between waves coming from upper half and lower half have what? Path difference of lambda by 2. Right. Both of it have lambda by 2. See class. Now what will happen? Two waves that have upper half is their upper half and lower half. This is from your concept of constructive and destructive interference. Look here. Upper half and lower half. So one from upper half, other one from lower half. Plus, minus, crest and trough. How do they superimpose on each other? They superimpose destructively. So that decreases the amplitude, that decreases the intensity, that decreases the minimum value of wavelength that we have, the path difference, the phase difference. So we get minima. What happened right now? From the upper part, the slit was divided into two equal parts. From the upper part, you have lambda by 2. From the lower part, you have lambda by 2. Both superimpose each other. But see, if only two waves, crest and trough are there, it means they'll overlap and that will result into destructive superimposition of the waves. So that's why it results in minima, because this is destructive, crest with trough. Now, if let's say 3 lambda by 2 is there, so how it results into maximum. See, now I'll divide the slit into 3 parts and I'll show you the difference why we are dividing the slit into 3 parts. So this, I have taken the single slit for the experiment. This is point A, this is point B. This is A. Now I have divided it into 3 parts. This becomes A by 3, this becomes A by 3, this becomes A by 3. Right, I have written it like this. Now see, waves that are coming, now they have a path difference of 3 lambda by 2. We have to show that they are resulting into a maximum. See, first two waves that are coming from here, from the first part and from the second part, they'll have a path difference of lambda by 2. The way now we have just studied above, right? They have a path difference of lambda by 2. Understood? Now see here, waves coming from these two paths have a path difference of lambda by 2. So they'll superimpose destructively. Simply from the first two parts, what will happen? From the first two parts, just the first two parts are similar to the one that we have just seen above, right? So it means these both of these will superimpose each other destructively, right? So one part will be left, 1/3 from the total slit will be left. So this part will be left. That's why this results into a maximum value, because even after destructive interference, you have an extra value left with you. You have a value that is left extra, which is this 1/3. That's why this results into a maximum. I'm repeating again. See, when we divided the slit into 2 parts, I have written the things. Okay, I've written the things behind also, so no need to Pari, I'll just give you time to note it down. See, from the two parts, from upper half, lower half, they have a path difference of lambda by 2. Agree. Now see what will happen. They'll superimpose destructively because one is from the upper half, second is from the lower half of second one, upper half of first one. That superimposes destructively. Fine. Same thing occurs if you have two divisions, but as soon as you get a third division, that gives you one more extra part that results into maximum. See, if you have 4 slits, if you divide it into 4 parts, you will just have destructive interference from above 2 parts, destructive interference from below 2 parts, right? But as soon as you take odd one extra part is left. So that extra part, no, that results into increment in the intensity, amplitude, path difference, phase difference, like this. Fine. So these are theoretical questions like this only. They'll change the value and can ask you same thing. You have to follow same steps. All right, note from here, make a note from here and then note it down. Then we'll discuss the difference between, and I think this is end of it. Now nothing is left. We'll discuss the difference at least because difference question can come in your exam.
Ma'am, can you show the first question again? Okay, ma'am.
Plus, as I was saying, just the difference part that we have to write between interference and diffraction. So let's discuss this. And now, since time is there, we'll start with dual nature. Interference and diffraction. See, first point is that this is from two coherent sources, superposition of light waves from two coherent sources, interference occurs. So superposition, not superimposition. Superposition of light waves from two coherent sources. And in case of diffraction, it is just superposition of secondary wavelets from the same wavefront. Right, from the same wavefront. No, wavelets from the same wavefront. So this is superposition of secondary wavelets from same wavefront. So basically definition, first point is definition that you all can write. Second thing is that bright fringes have same intensity. All the bright fringes or maximum one, they have the same intensity. So you can say bright fringes or maxima term you can use have same intensity, because obviously dark is dark. Dark's intensity does not decrease because dark means absence of space. So intensity will be observed for the bright fringes only. So that's why bright only. Here intensity decreases. Intensity decreases. Intensity of maxima decreases, right? And regarding the fringe width also, see, all the fringes have the same width. I'm telling you, same fringes are observed on the screen. Same fringes are observed. So here you have all fringe have same width. All the fringes have same width. Third point here, fringes, they can have different width. Fringes can have different width. One last point that, see, there's a good contrast between bright and dark fringes in case of interference. You will clearly observe, yes, this is dark, this is bright. You don't need to cover all the windows and doors and make the room dark to observe whether you're able to see the brightness or not. No, it has a good contrast. So good contrast between bright and dark. Here, poor contrast is there. Contrast is poor. So poor contrast between bright and dark fringes, or maxima or minima. Instead of term fringes, it's better if we use maxima or minima. Rest of the differences you can identify. If it depends on whatever marks your question is there. So if it's for 5 markers, these points with a diagram and with the examples, or same thing with just the intensity distribution curve, all these can complete your full 5 marker question as well, even if it comes. So chances of this is less, it's quite less, but in your theory question, it can come because there are contrasting differences between them. Note it down. Any doubts you have from this lesson, let me know. Then we'll start with dual nature of matter and radiation. So that is also not a big lesson now. See class, this is a very, very theoretical chapter. Now you have mostly theoretical chapters. So numerical part will be there from photoelectric effect that we'll discuss. But see class, the maximum theory part that is present and every definition and all, I'll share handwritten notes with you. I have certain handwritten notes that I'll share with you. Fine. So then that I'll share later on. Let's just discuss what are the main points of it. Main points of this dual nature of matter and radiation. So dual nature means basically what you've studied. Wave and particles, right? Particle theory we have studied. That a wave is that the radiations, these are just made up of particles. And one theory says these are made up of waves. So dual nature, we deal with both of it, like wave optics, what you have studied, as well as ray optics. Fine. Now see, very first concept that comes is the concept of photoelectric effect. Photoelectric effect is important. So photoelectric effect. Now see class, free electrons in metals, never in metals. Electrons in the outer shell of the atoms, these are loosely bound. Whenever, let's say, I think I have discussed this with you in case of a current in current electricity as well. You have electrons which are free bound and you have some mobile electrons. These are electrons, these are known as free electrons. So basically these free electrons are present, right? They can, some positive charges are also present, some ions are also present. So, but however, the free electrons remain confined to the conductor and cannot leave its ordinary at any temperature or any under moderate electric field conditions. It cannot leave it just like this. Otherwise, electrons would have escaped from any of the surface unless and until a minimum amount of energy is applied on it. A minimum wavelength is applied. A minimum frequency is applied. Every electron has its own value, has its own threshold. Until and unless that is crossed, the electron will not leave it. Free electrons means it has the tendency to move. It can move, but it can only move when a certain wavelength, energy, or frequency, any of these is applied. So that minimum amount of energy, that is required by an electron to just escape from any metal surface, that quantity is known as work function. So work function is basically minimum amount of energy. Minimum amount of energy to free electron from metal surface. All right. Now, one energy that is gained by electron, that is expressed in terms of electron volt. Electron volt. So one electron volt, it's basically the kinetic energy. Whenever we write 1 electron volt, it's basically the kinetic energy. And how can we convert it into our SI unit? One SI unit is fixed, no? One SI unit that we have. See, electronic charge. What is the electronic charge? Chapter 1, we all discussed. Electronic charge is what? Charge on an electron. Class, what is the charge on an electron? Yes. Khalid. Electronic charge.
So, teacher, could you repeat the question?
Electronic charge, electronic charge. Your internet is fine, Khalid.
I'm a bit disconnecting, but yeah, it's fine.
Now I think, now you're able to hear me, no?
Yes.
Electronic charge. What is electronic charge? As soon as I ask a question, Salman's internet definitely goes away at that very moment. Yes, Khalid.
Current passing through a particular time.
No, value. Why will I ask you the definitions right now? Value, one electronic charge.
1.6 into 10 raised to minus 19.
Yes, exactly. I hope you've answered it by yourself only, Khalid, not from seeing anywhere.
No, teacher, I remember this. Yeah.
Yes. Okay, good then. Exactly. This was which I was asking. So 1.6 into 10 to the power minus 19, just add joules. That is how you convert 1 electron volt into joule. Now, see, class, there are different types of emissions that are possible. One is thermionic emission. Let me just write the names. As I've told you, I'll share the definitions. No, and these are also not needed. Just there are the types of energies that are present. One is known as thermionic emission. So thermionic emission means when thermal energy is required to escape this electron or make this electron free. Fine. Another is field emission. Field emission means, or this is also known as cold cathode emission. When the cold cathode produces such amount of energy, high electric fields are produced in the power of 10 to the power 8, 10 to the power 9, like this, then it frees the electron. Now, this type of emission is known as field emission. Then you have a third type of emission that is known as secondary emission. So secondary emission, when a fast moving electrons strike a metal surface, they sometimes free electrons. They transfer energy. So transfer of energy from other electrons. This can also free the other electron that is present. Last one that is very important is photoelectric emission. Photo means what? Photon simply means light. It means when the sunlight is used, whenever light is used, any light you can say. Now, electrons are emitted from metal surface, electromagnetic radiations are used. So when light emits electrons, that type of emission is known as photoelectric emission or photoelectric effect. So photoelectric effect is what? This is important now. Photoelectric effect. Whenever a suitable frequency of light is present, that strikes the metal surface and it releases the electron. In the sense, let's say this is certain cross section of wire. Electrons are present. These are negatively charged electrons. A certain frequency was needed for the electron to be free, and that free electron's frequency was hit by this electron. This way. Now this electron will come out. It means emission has occurred, and this type of emission that has occurred because of light rays. This is known as photoelectronic emission. So when light of suitable frequency illuminates a metal surface or strikes a metal surface, you can write electrons are emitted, and that emission is known as photoelectric effect. Electrons from the metal surface are emitted. So this is called photoelectric effect. All right. So Hertz also did certain observation. Hallwards and Lenard's observations were also present, and through all the observations, it was concluded that emission of electrons from a metal surface when electromagnetic radiations or any light ray that has a high frequency is generated, that is known as photoelectric effect. And such type of electrons that are emitted from photoelectric effect, these are known as photoelectrons. These are known as what? These are known as photoelectrons. So an experiment was also done where glass tube was connected, an effect of intensity was seen of photoelectric current, effect of frequency was seen on photoelectric current. Before we start with the classical wave theory, Einstein theory of photoelectric effect is also there. All these points are there. Note this down, then we'll do what is the effect of intensity on photoelectric effect and frequency. This we'll do. note down the point, just make small points like this only. See, experiments, when experiments were done, no, experimental studies were done on photoelectric effect. So proper glass tube chamber was connected. I'll tell you, let me show a rough diagram so that you can understand this. Last part this week, then you all can start with your test. So this is Wednesday, no? So Monday we'll try to complete with this because photoelectric effect is there in your syllabus. Work function, kinetic energy, numericals from there only come. So entire photoelectric part comes. And what else is now left in your? That is Davis and German's experiment is deleted. Photocells are deleted. De Broglie waves, I think. De Broglie waves, I just have to check whether de Broglie waves are included or not. De Broglie waves, if they are included, they'll have certain questions. Otherwise, these two topics are just there in dual nature. De Broglie waves and photoelectric effect. So on Monday, we'll be able to finish with this lesson. Fine, let me just discuss what I was discussing. Yes. A proper evacuated glass tube was connected. And an outlet was made for light rays to enter. Cathode was there, anode was there. Anode was even connected to a microampere ammeter. And this part was connected. Voltmeter was also connected just to regulate the voltages, and rheostat to regulate current, key and everything. This setup was there. I'm not drawing everything. So cathode, anode. Electrons are there. As soon as the light ray strikes onto this, the electrons move towards the end. So what was observed? Proper conduction was observed. See, some more things were also there. This you must have done in your chemistry, structure of atom. It's also included in structure of atom. So there you have the details for this experiment. In physics, you do not have the details. But what was observed? Few things were important, like the effect of intensity. What was done? That intensity was increased. Slowly, the intensity was increased. The way you perform physics practicals in your school. Same thing, same way you have, these experiments were done. So this is photoelectric current. And this is intensity. So this is the graph that was observed. That photoelectric current was directly proportional to the intensity. So as soon as you will increase the values of current, this will be increased to as you increase the value of incident current, this will increase the intensity. Fine. This was the effect of intensity, one graph that you have. One more graph that is present. Is the graph of stopping potential. This needs space. It's already 10. No? Do one thing, class, note it down because your questions just need some time as well. Note it down, note just this graph down. I'll continue from here on Monday only when we'll have a proper 2-hour class. No? So 2-hour class, I'll complete with photoelectric effect and half an hour will be required for de Broglie if it is included because Davison and Germer's experiment is deleted. Note this down. Let me share your question paper. Yes, class. Open up your cameras. Start with the test. 6 questions are there. They'll take time. So start with it. That's why I have started the test right now. So switch on your video cameras. Focus mode is already on. And start with the test. Any doubts you have, let me know. And again, similarly, like the last test, those whose cameras will be on will only be considered. Those test papers also have to show you. Just remind me once, one more thing, class. I'll check and let me know. Apart from the last test papers that we had, did we have any other test paper that was left unchecked? Let me know, because I want to send your scores as well. No, scores are also piling up. Papers are there. So one was the test that we had last time. If apart from it that you have, do let me know. And yes, class, your time has started. So till now, Salman has only made an effort. So his paper will be considered. Do not switch off your cameras in between class. Simply switch on your camera, attempt the test, submit your sheets, and you can leave. And again, repeating, I'll not check the papers whose camera is not open.
Teacher, for the first question, how many necessary conditions should we state?
Two conditions are enough for it.
Okay.
Again, for the last time I'm announcing this, only Salman has opened up his cameras. I'm only able to watch and invigilate Salman. Rest of you, Khalid, Memuna, by yourself, you can check your sheets, because I have told you if there is specific issue, then text me in the chat box. Otherwise, the way last time we had the test, same test we are going to have it right now.
No, I'll turn off my camera for taking photos. Okay. Thank you, ma'am. I'll be leaving.
Yes, Salman.
No, I have sent it in the group.
Okay, okay. Just let me just check. Yes, sir. Okay. Thank you so much, Salman. Allah Hafiz.
Thank you, ma'am.
Teacher, I'll turn off my camera for submitting. Teacher, I submitted.